we've got a forest out there, and many of you have seen this now in the summers. Fortunately, this summer we had a relatively smoke-free summer. But this is why. This forest here is up by 49 degrees north. This landscape is supposed to have 80 to 100 trees per acre. There are 4,000 to 6,000 trees per acre on there. And we are now in what's called the era of mega fires. Now, fire was always here. I see a lot of people, in my opinion, confusing climate change and wildfires as wildfires being a result of climate change. As a matter of fact, I think that science shows us that the carbon emissions from wildfires are creating a carbon source rather than a carbon sink from our forests. And we need to switch that, and we need to do that rapidly. And you hear people like the Nature Conservancy saying CLT is the answer, but it's got to be 10 to 100 times more than what the industry sees it being right now. And that's what we end up with. So there's a solution here that is much different than this. And this is actually up on the Colville National Forest. This is up on Boulder Pass. It's in Ferry County. And the real sad part about this situation is we had collaborated with the environmental community to manage this and thin it out, and it burned the month before it sold. So there's 2 years of work that we put into that. And then, and salvage operations, which are taking the trees out, we can still utilize them, but that's not something that we've got worked out with the environmental community yet, because there's some soil issues and a bunch of other things that we need to consider. What we'd like to do is get to them first, go out there with high-tech equipment, manage that forest, and what we're building is the byproduct of good forest health, good forest restoration, not an extractive industry where we're taking timber out of the forest. This is what it looks like. Down there, I'm on the board of Sustainable Northwest in Portland, Oregon, and this was a board visit to one of our projects up in Colville. Our collaborative group with environmentalists has resulted in some pretty amazing things. The Colville National Forest is 1.1 million acres. About 450,000 acres of that forest are manageable for timber-related activities. Most have been neglected since the mid-'80s, so we have wildfire danger basically everywhere. So we collaborate with the environmental community to create these projects that are supported by the local, regional, and some national environmental groups. And the results are that the Colville National Forest is the most productive forest in the nation. It's 400,000 acres of manageable land out of 193 million acres across the country, and it's the most productive. And it's not because we focused on the volume, it's because we focused on what the forest needed. And that's what we should be seeing more of. And that's the aftermath. So that's really the product, right? Because we want healthy forests. So what we're doing is we're creating a business, and I'll show you how we get to the product through here. So this is a Scandinavian sawmill design that is used for my family's company, Vaagen Brothers Lumber in Colville. They also have mills in Usk and Midway, British Columbia. But the log goes through there in a single pass, very rapid pace. So this pattern, which would be a 2x4 on the top and bottom and two 2x6s in the center, would go through that machine somewhere in the neighborhood of 500 to 650 feet per minute, depending on the species. So we can do like 17,000 logs in like an 8 or 10 hour shift. So it's highly efficient, small diameter processing. This is the lumber that comes out of it. Small trees, people think, oh, that's not going to create a good quality product. They grow slower in these forests because they don't have the nutrients. Well, what ends up happening is they have tighter growth rings, which makes them stronger and more dense. So then when we take that and we use new high-tech ways of adhesives and adhesion to make products like cross-laminated timber, we can now build new buildings faster, better. So what I'm trying to show here is I believe that there's a convergence here on forest management and on the way we build our buildings. So we started Vaagen Timbers, I think I filed the LLC paperwork in 2016, and then, you know, most startups, there's a whole process behind the scenes that nobody sees, and started putting a team together. this was, this came up on my social media feed. This was a year ago. And that was, that's a, let's see, 200 by 200 foot building right there. We added another one off the back that the whole thing amounts to 68,000 square feet. And today it's done and we're producing product. So in a year, I'm pretty confident in what we've done, and I'm pretty pleased with what we've been able to achieve. We also created a commodity product because we had to make finger jointed lumber in order to make the long pieces to make cross-laminated timber. So we make a structural finger jointed material that goes into the truss market in places like Texas and Birmingham. So that allows us to create revenue as we're kind of spooling up the business. And we'll do that because we've got more capacity on the front end than we do on the rest of the line. So this is our probably our second set of panels that came through there. They look pretty good. We're very happy with the way that came together. We went and searched the globe for to benchmark the best technology in cross-laminated timber and glulam beams, and I think we found it in a place called Lem, Denmark, which is the far western edge of Denmark. It's a little tiny town. It happens to house Caliso, the manufacturer of this press. I'll talk about that in a second. And their next door neighbor is Vestas. Does anybody know who Vestas is? One of the largest wind turbine manufacturers in the world. They also do a lot of manufacturing for Vestas too. So it's pretty interesting to go to these tiny towns in the middle of nowhere around the world. And there's all kinds of amazing manufacturing going on. So their press is unique because it uses high frequency technology. There's a small radio frequency generator on the side. It then has massive amounts of power applied to it. And then we have 150 psi of pressure on the top and the sides. And when that panel goes through there, it's got that high frequency along with that pressure. The high frequency finds the conductive layer of the glue, vibrates, creates heat, and rapidly cures that process. So if we were to do this in a cold set, which most manufacturers are doing it, it would take somewhere like 30 to 45 minutes. And then it takes another 24 hours to cure. We're curing right now about a minute 20 per layer, and we pulse it through 20 feet at a time. So we're able to, with a 20-foot press, we're able to produce 60-foot long elements. And we can do a 60-foot long element on a 3-ply in about 10 minutes. So, and it goes directly to our CNC, which is right here. So that has 2 robots in there. What we do with our clients is we sit down from the very design element of the design phase of the building to figure out how to spec our product into their design. And then when we put things out, it's not a commodity. It's a specific designed element that gets assembled once it gets to the job site. So we get the 3D renderings from like a Revit model or what have you. We put it into our CADWorks software, which is designed for wood and connections and all these things. And then it takes it and enters it into the software of this program to cut those exact elements. We're working on trying to develop software to talk all the way through the process. So when we put a project into the queue, it orders the lumber from the sawmill. So we don't have any inventory issues. We just want to really intelligently handle this stuff. And then we want to be able to scale this thing because we think that there's great opportunity. This was our first project going out. There's a lot of irony in this product that's going out. This actually is, let's see, it's got about 6 more weeks to hit the port of Helsinki. This is a set of, it's really kind of funny. It's a set of panels that's becoming cubicles inside of an uninsulated building in a very cold environment so they can control the temperature. And you'd go, well, there's CLT production in Europe. They're the leaders. Well, it's not available, 1. 2, the guy that owns this company is a very close friend of mine, and he supplied the sawmill equipment to our sawmills, and he really wants stuff that went through his sawmills in North America to be in his structure. So we were happy to create the first project for them. This gives you an idea of how these things are built. Now, there's a few slides here that I'll go through. they're all done by Andrew Waugh, who I think is the premier timber architect in the world. The last slide I'll show you will demonstrate why. This is actually his the center apartment in the top 2 floors there, that's actually his apartment. And it just shows how this stuff goes together. It's a lot of design up front, but once you install it, it goes very rapidly. And this is clad in brick, so you would never know it was built with timber. Here's one of the first high-rise buildings. I think this is a 9-story. Very, you can see the CLT, a lot of honeycomb in there, and then the actual building on the right. This building sold out in 1 hour and 43 minutes. And they have an annual event every year with the owners because they love it so much. And the turnover there is like almost nil. So here's a diagram of what's currently, and it won't be for long, these will keep changing, but currently the largest timber structure in the world. It's 10 stories, about 170,000 square foot footprint. There's a drawing, and there's where it's at today. Well, it's actually probably done today, but that was recently. So before I close, we're about to deliver, starting next week, the first locally sourced and delivered CLT panels to Spokane in the South Perry district. There's a group that's been putting together a modular setup for CLT design. It's called Blockhouse, and Andy Barrett's here. He's got a lot of experience in doing modular things with containers, and now he's using CLT to apply that same thing. We're getting a lot of attention from others that want to see CLT, the high quality it brings to modular construction for the living environment and that kind of thing. But that's really exciting. So that'll start next week. Hopefully panels will be flying into place on Tuesday, and then we'll have, it's 14 units. I think that comprises 8 buildings. There's a couple of them that have 2 units per. So that's really exciting. The other thing I'd like to say is we're kind of, we don't know if we're gonna do another round of funding. We did one. I've funded a lot of it, but we have some investors, Tom Simpson namely, so if any of you are part of his funds, you're invested in Vaagen Timbers. He's been not only from an investment standpoint, but from a mentor standpoint. Tom Simpson, if you don't know Tom, you probably should, because he's pretty awesome. But we are looking to do some things, not only with Vaagen Timbers and scale up. We should be able to cash flow this month, which is pretty exciting. And then what we see as, now that we've gotten into this, as an opportunity is some more digital fabrication downstream. Because in North America, we like to produce high-level, high-speed commodity products. We don't particularly do well in wood products in particular with doing things on a one-off basis. Most of it's done on put as many boards out as you can and just wash it out into the marketplace. And so we see some of the folks that are in the CLT right now that they want to produce a lot, they want to drive their costs down. Rather than try to buck that trend, maybe we'll take advantage of it and put more digital fabrication out there, buy those panels and get those into structures. And one last thing, to give you an idea of the change in scope from traditional wood products. In the lumber business, a big customer is about $2 million annually. There's a lot of them. And for us yesterday, we were, I think we may have got it. We were talking about a project in San Francisco, and our portion of it, it's like a 4 or 5 story project, not particularly large, is about $4 million. So we don't have to have 200 units under our belt in order to get a good order file. We need half a dozen big projects, some really cool residential ones, and we're going to be off to the races. So thanks for your time.
Thank you, Russ, very much. I have too many questions, so they'll save for later. Do we have any questions? We'll have one question, and then we're going to go to break.
Russ, what's the insulating quality of the panel, and do you need to add insulation to your building built?
The question was about insulation. We get that a lot. The R value of the 5-ply panel is like 6.5, so it's not really that high. But there's going to be a lot of research done because it has thermal mass. So once you heat it up, it doesn't transfer heat out. So the R value is a real inaccurate way to do it. With codes, we will have to do a lot of insulation on it, like an exterior. We'll do like a vapor barrier, put some rigid insulation on and siding, and that'll work perfectly. Actually, we'll be able to achieve passive house and things like that. I think over time we'll learn more and the codes will accept the product for its insulated properties beyond just an R value.
Okay, we have one more question.
Yeah.
So I worked in the architecture industry for about 3 years, and I see it as one of the slowest industries to accept change, especially engineers and construction managers. And so I'm curious what you're doing to educate the market through your marketing to move that quickly.
So you're absolutely right. It is slow to change. I tell people that what we're doing is kind of like the Legos, for those of us that are in our 30s and 40s. Remember, you used to get Legos, there's just a big pile of them. It's like, we'll build something, and it would be different colors, and it would kind of look like a building or whatever you built. But now you go to the Lego store, and you can pick up the Millennium Falcon, right? And 186 steps later, and a bunch of different bags lined up, you built this thing, and it's almost, if you did it right, perfect rendition of what you went out to do. It's assembly, right? It's following directions, and it's highly engineered. And the people in Billund, Denmark that make Legos, which is right next to where our press is manufactured, they changed everything to be into assembly instead of construction. And so that's how we build buildings now. We put a bunch of materials out there and we say, okay guys, go build something. And it mostly looks like the way we designed it. And sometimes it performs like it or it doesn't. So what are we doing specifically? And that was your question. We opted to go with a narrower panel. So our panels are 4 feet in width. And some people go, well, why would you do that? I mean, CLT is supposed to be big. We did it because we're open to every logistical channel open to lumber and building products today. So if you want to build with traditional materials and you want a CLT floor deck or you want an overhang just for visual purposes, you can do that. What our interpretation is, based on what we've seen around the world, is as soon as they do that, they're going to go, well, why don't we use this for the walls? It'd be a lot faster. Because you're talking about buildings that would be traditionally stick frame. And we're just talking about stick frame, we're not talking about steel and concrete yet. But stick frame that would take 15 to 30 framers and take this long period of time, and there's not that many framers, so each crew is stealing from another one when they bid the next job, so it's this constant problem. If they could do that with 5 or 6 of their core people, and they could do it in half the time, that's where it'll get to. But it does take being able to enter the elements in there in a way that they can understand it. That's our interpretation, and so we're trying to go that way.